It is the 21st of November, 1939, and the Thames estuary is cold, grey, and deeply suspicious. A German Heinkel. He 115 float plane skims low over the dark water off Shoeburyness, its engines muffled to a drone beneath the overcast sky. The crew knows they are pushing their luck. British coastal radar is improving by the week, and RAF night fighters are increasingly active along the eastern approaches. But the crew of this particular aircraft is not here to bomb anything, not here to strafe a convoy or photograph a harbor. They're here to drop something into the water, something cylindrical, roughly 2 meters long, trailing a parachute, and then leave as quickly and quietly as they came. The weapon drifts down through the grey November air and strikes the mudflats at low water, close enough to the surface that a sharp-eyed Royal Navy observer on the shore can see exactly where it lands. The Germans, of course, do not know this. They believe their new weapon has disappeared into deep water, lost to the tidal murk of the estuary, invisible and lethal. What they do not know is that within hours, a team of Royal Navy officers, 2 of them Lieutenant Commanders John Ouvry and Roger Lewis, will wade out into that freezing mud, wearing nothing more protective than their standard uniforms, carrying improvised non-magnetic tools fashioned from brass and bronze, and begin the most dangerous act of improvised engineering the war has yet produced. They're going to disassemble a German magnetic influence mine. Lave. In the dark. For the first time in history. What they discover inside that cylindrical steel casing will not simply save British shipping. It will eventually be turned back against the very force that conceived it, transformed from a weapon of German aggression into the mechanism of German destruction. The technology buried in that mine, the magnetic influence fuse, designed to detonate beneath a ship's hull without contact, will be studied, reverse-engineered, and refined until it becomes something the Kriegsmarine never anticipated. A booby trap set by the hunted, sprung by the hunters, in waters the Germans believed they controlled. This is the story of how Britain took one of the most feared naval weapons of the Second World War and weaponized it against its creators. To understand why this matters, you have to understand what German mines were doing to Britain in the autumn and winter of 1939. The war was barely 3 months old, and already the Royal Navy and the Merchant Marine were bleeding from a wound they could not locate. Ships were not being struck by torpedoes from identifiable U-boats. They were not being bombed from above. They were simply exploding, in ports, in estuaries, in convoy lanes. The losses were staggering and deeply alarming. In October alone, several vessels were lost to what the Navy initially classified as unknown causes. The passenger ship City of Paris was damaged. The destroyer HMS Gypsy was sunk off Harwich. The cruiser HMS Belfast, then one of the most powerful cruisers in the Royal Navy, was catastrophically damaged in the Firth of Forth and would spend 3 years under repair. The cargo losses across the merchant fleet were worse still, less dramatic, but cumulatively devastating. Britain imports the vast majority of its food, its raw materials, its petroleum. Every ship that sinks is a hole in the national stomach. The instrument causing all of this was the German magnetic ground mine, the LMB, the Luftmine B, dropped by aircraft or laid by surface vessels in shallow coastal waters where British shipping had no choice but to pass. Unlike contact mines, which required a ship to physically strike a moored sphere bristling with Hertz horns, the magnetic ground mine sat passively on the seabed and waited. It did not need to be touched. It simply needed to sense the magnetic field distortion caused by a large steel ship passing overhead, at which point its fuse would complete a circuit and the charge, typically 300 kilograms of hexanite explosive, would detonate directly beneath the ship's keel. This was not a new concept. Magnetic fuses had been theorized for decades, and the British themselves had experimented with them during the First World War. But the German implementation in 1939 was sophisticated, reliable, and, crucially, invisible. There was no way to sweep a ground mine using conventional paravane gear, which was designed to cut the cables of moored contact mines. The magnetic mine simply sat there. You could not find it. You could not cut it loose. You could not drag it to the surface. The only thing you could do, before Overy and Lewis waded into that Essex mud, was try to avoid the areas where it had been laid. And even that was becoming impossible. Britain needed to understand how the fuse worked before it could defeat it. And to understand it, someone had to take one apart. Overy and Lewis succeeded. Working with brass spanners and non-magnetic screwdrivers, pausing after every turn of every bolt in case the motion itself triggered a trembler switch, they removed the fuse assembly from the Shoeburyness mine intact. It was taken to HMS Vernon, the Royal Navy's torpedo and mining establishment in Portsmouth, and there a team of scientists and engineers, including experts from the Department of Scientific Research, subjected it to thorough analysis. What they found was elegant in its simplicity. At the heart of the fuse was a small magnetic needle suspended in a sealed capsule, rather like a compass needle but oriented vertically. Under normal conditions, the Earth's magnetic field held this needle in a fixed position, but when a large steel vessel passed overhead, its own magnetic field, every steel ship carries one, generated by the alignment of iron molecules during construction and the accumulated effect of the Earth's field over years of operation, would pull the needle downward. When the needle deflected far enough, it completed an electrical circuit. The circuit fired a detonator. The mine exploded. It was, in engineering terms, beautifully conceived. The sensitivity could be adjusted by moving the needle's mounting point, allowing the mine to be set to detonate only under vessels above a certain size, which meant minesweepers, being smaller, might pass over without triggering it. The Germans had also incorporated a ship counter, a small mechanical device that could be set to allow a fixed number of vessels to pass before the mine became active, making clearance operations even more hazardous. A minesweeper might pass safely 3 times and then be destroyed on the 4th pass, having assumed the area was clear. The answer to the magnetic mine, the degaussing of British ships achieved by running a large electrical current through a cable looped around the vessel's hull to cancel its magnetic signature, was developed with remarkable speed once the fuse was understood. By early 1940, degaussing cables were being fitted to Royal Navy warships and merchant vessels at a rate that speaks to genuine institutional urgency. The principle was straightforward. If the ship carried no net magnetic field, the mine's needle would not deflect and the mine would not fire. But the British did not stop there. Understanding the fuse gave them something more than a countermeasure. It gave them a blueprint. The facility that turned the German fuse concept into a British offensive weapon was the Directorate of Miscellaneous Weapons Development, an organization whose deliberately uninspiring name concealed some of the most inventive technical minds in wartime Britain. Working alongside the Royal Navy's mining department and drawing on research conducted at HMS Vernon and at various university laboratories under contract to the Admiralty, British engineers developed what would become the Mark I magnetic mine, and then a series of progressively more sophisticated variants that incorporated everything learned from the captured German example, and a great deal more besides. The British magnetic ground mine was, in its basic form, a cylindrical steel case roughly 1.5 meters in length and weighing approximately 680 kilograms in its aerial delivery version, the Mark V, which became the most widely used variant. The case was painted a non-reflective dark color and was designed to be dropped from aircraft at low altitude, slowed by a parachute to prevent damage on water entry, and to settle on the seabed in waters up to about 55 meters deep. The charge inside, Torpex, a British explosive compound roughly 50% more powerful than TNT by weight, was typically between 270 and 320 kilograms, depending on the variant, The fuse assembly at its heart was a direct descendant of what Ouvry and Lewis had extracted from that German mine on the Essex mudflats, but refined considerably. British engineers added a hydrostatic safety device that prevented arming until the mine had settled at a certain depth, ruling out accidental detonation during the drop. They added a clock delay mechanism that could keep the mine inactive for up to 16 days after laying, so that clearance operations launched immediately after a mine-laying raid would find nothing. And then, a fortnight later, the mines would arm themselves and the shipping lanes would suddenly become lethal again, without warning. Most cunningly of all, they retained and improved the ship counter. British mines could be set to ignore the first vessel to pass, or the first 5, or the first 10, before becoming active. This made systematic sweeping extraordinarily dangerous, because sweeping crews could never be certain they had cleared an area simply because their sweep vessel had survived multiple passes. A route that appeared clean might be lying in wait. Production of the British magnetic mine took place primarily at the Royal Ordnance Factory at Chorley in Lancashire, supplemented by facilities at Bridgewater in Somerset and Pembrey in Wales. Exact production numbers remain partially classified, though post-war analysis suggests that somewhere in the region of 45,000 to 50,000 magnetic influence mines of various marks were produced by British facilities between 1940 and 1945. A figure that, if accurate, represents one of the largest single-weapon production efforts of the war. The first large-scale British offensive use of the magnetic mine came in the spring of 1940, when the RAF's No. 5 Group Bomber Command began mine-laying operations, codenamed Operation Gardening, in German and German-controlled coastal waters. The aircraft used were Handley Page Hamptons initially, later supplemented by Avro Manchesters, Short Stirlings, and eventually the Avro Lancaster, which could carry a single large mine in its bomb bay with relative ease. The targets were not chosen randomly. Operational planners focused on the Kiel Canal, the approaches to Hamburg and Bremen, the Frisian coastal lanes, the approaches to Wilhelmshaven and Bremerhaven, and, with particular strategic intent, the waters off the Norwegian coast used by German iron ore carriers, bringing Swedish ore south from Narvik. Iron ore was the lifeblood of the German steel industry, and the Norwegian coastal route was the artery through which it flowed. Sow enough mines in that channel, keep them cycling through their delay and counter settings, and you did not simply sink ships. You slowed the entire flow of raw material into Germany's war machine. The results, in operational terms, were frequently invisible to the public, but significant in aggregate. German records captured after the war indicate that British magnetic mines sank or damaged somewhere in the region of 700 vessels between 1940 and 1945. A figure that includes surface warships, U-boats in transit through mined channels, and merchant vessels of all sizes. Some of these losses were individually dramatic. The German destroyer Z-21 Wilhelm Heidkamp was sunk by a mine in Narvik Harbour in April 1940 during the Norwegian campaign. Several German minesweepers, the very vessels tasked with clearing British mines, were themselves destroyed by the weapons they were hunting, killed by ship counters that had waited patiently for exactly such an eventuality. If you are finding this interesting, a quick subscribe helps more than you know. And then there was the effect on the German mine-laying force itself. Because British mines were being laid in the same coastal channels that German mine layers used, and because those channels were narrow enough that there was no route around, German vessels laying their own mines in British waters would return home through channels that British aircraft had mined the previous night. The hunter, passing over ground it believed to be safe, would strike a weapon it had not known was there. The irony was not lost on the men of number. 5 Group, who maintained careful records of which channels had been sown and when, and who understood that every mine laid in a German shipping lane was a standing threat to any German vessel that used it, including those on mine-laying missions of their own. To appreciate what Britain achieved, it is worth comparing the British magnetic mine program with the German effort and with what the Americans were simultaneously attempting. Germany's LMB remained a formidable weapon throughout the war. The Kriegsmarine and Luftwaffe together laid an estimated 22,000 mines in British waters during the war, and these caused significant losses. Somewhere around 260 merchant ships and a number of Royal Navy vessels. But the German program suffered from a crucial vulnerability. Having laid their primary weapon in November 1939 in recoverable water, they had handed their adversary the keys to the system. British degaussing rapidly neutralized the LMB's effectiveness against military targets, and the countermeasures program, once established, extended to the merchant fleet with impressive speed. Germany responded by developing more sophisticated variants: the acoustic mine, the pressure mine, the combined influence mine that required both a magnetic and acoustic signature to detonate, and these posed serious ongoing challenges. But the British program kept pace, in part because the Admiralty had established a systematic process of recovering and analyzing every new German mine variant that could be located, feeding the results directly back into both the countermeasures program and the offensive mine design effort. The American approach, developed in parallel and partly informed by British research shared under the Atlantic Cooperation Agreements, produced the Mark 25 influence mine, a large, sophisticated weapon primarily designed for deep water and aerial delivery. American mine-laying in the Pacific, particularly Operation Starvation in 1945, the systematic mining of Japanese home waters by B-29 superfortresses, is credited by post-war Japanese analysis with sinking more shipping tonnage than any other single Allied campaign in that theater. The operational principle was identical to what British Hamptons had been doing over the Kiel Canal since 1940. The Americans had the aircraft to deploy it at scale. The British had developed the doctrine first. No other Axis power produced a comparable offensive mining program. Italy's mine warfare effort was largely defensive, focused on protecting harbor approaches and the central Mediterranean. Japan relied heavily on contact mines and lacked a systematic influence, mine production capability comparable to either Britain or America. The legacy of the British magnetic mine program is, like many of the most effective weapons, difficult to quantify precisely because its effects were cumulative and dispersed rather than dramatic and visible. A bombing raid produces photographs, casualty reports, before and after aerial imagery. A mine campaign produces, largely, the absence of ships that never arrived. What the historical record does show, with reasonable clarity, is that Operation Gardening cost Germany significantly more than it cost Britain to run. The RAF flew approximately 17,000 gardening sorties during the war, losing around 470 aircraft, a loss rate of roughly 2.7% per sortie, comparable to or better than losses on many bombing missions over Germany, and against targets of genuine strategic significance. The number of gardening sorties exceeded those of almost any other single RAF Special Operations task of the war. German records indicate that the coastal mine-laying campaign required the permanent assignment of large numbers of minesweepers, mine hunters, and support vessels to defensive sweeping duties throughout the war. At certain periods, estimates suggest that Germany was devoting as many as 40,000 naval personnel to mine countermeasures. Personnel who could not be assigned to U-boats, surface raiders, or coastal defense. The logistical burden of keeping mined channels clear was, in effect, a second front imposed on the Kriegsmarine by the RAF's gardening crews and their cylindrical cargo. Surviving British magnetic mines of the period can be examined at the Royal Navy Submarine Museum at Gosport, and a number of examples exist in private and institutional collections across Scandinavia, where post-war clearance operations recovered them from coastal seabeds. The Mark V, the most widely produced variant, is a somber-looking object at close quarters. No more dramatic in appearance than a large hot water cylinder, which is roughly what its size and shape suggest. It is difficult, looking at it in a museum case, to connect this dull, dark object with the strategic paralysis it could impose on an entire shipping lane. But that is perhaps the point. The most effective weapons are not always the most impressive ones. Return now to that November morning in 1939. The grey water, the mudflats at Shoeburyness, two naval officers walking out across the tidal flat with brass tools in their hands and, one imagines, very specific instructions to their families about what to do if they did not come back. What Ouvry and Lewis did that morning was not simply an act of physical courage, though it was certainly that. It was an act of disciplined, analytical courage. The courage to approach an unknown weapon not with fear, but with curiosity, to treat the thing that was killing British ships not as a mystery to be avoided, but as a problem to be solved. And in solving it, they opened a door that Britain would spend the next 5 years walking through, carrying cylindrical steel packages to drop into German harbors, German canal approaches, German iron ore routes, German mine-layer channels. The irony of the magnetic mine's wartime career is precise and satisfying. Germany invented it, deployed it with devastating initial effect, and then watched as Britain mastered it, improved it, and deployed it back. Not in British coastal waters where it had first struck, but in the very channels the Kriegsmarine depended upon. German minesweepers hunting British mines were sunk by British mines. German mine layers returning from operations against Britain passed through waters sown with British weapons, and sometimes did not reach home. The weapon that was meant to strangle Britain's maritime lifelines became a standing hazard in Germany's own back garden. Consider what the program achieved in its aggregate. Close to 700 vessels confirmed sunk or damaged, 40,000 naval personnel diverted to defensive duties, iron ore shipments slowed, U-boat transits disrupted, and all of it achieved by a campaign that barely registered in public consciousness, flown at night, recorded in operational logs, filed under a code name chosen specifically for its innocuousness. Gardening, as though the RAF were doing nothing more dramatic than tending their allotments. They were, in a sense, patient, methodical, returning season after season to the same channels, sowing the same seeds, and the harvest, though it came slowly and was never spectacular, was real. The magnetic mine did not win the war. Nothing so simple wins a war. But it imposed costs on Germany that Germany could not easily afford, sustained over 5 years, applied with increasing sophistication, drawing directly on knowledge extracted from a German weapon that had been carelessly deposited in recoverable water on a November evening in 1939. Germany made a weapon. Britain made it better. And then Britain made Germany drown in it. If you liked my video, please share your opinion in the comments box and subscribe to the channel. Also, turn on the bell icon so that the latest videos like this keep reaching you. See you in the next video. Take care and goodbye.